Hello everyone, welcome back to my YouTube channel. So we were discussing thermodynamics chapter and today I'm planning to discuss isothermal process. So it's night and I'm in a mood to enjoy. So I came here to disturb you. Okay? Okay. So today we are going to talk about isothermal process. Okay? So this thermodynamics is really important chapter from NEET and JEE perspective. Isothermal process, if I talk about, this is very crucial, very important topic for this from this thermodynamic process. है ना? So isothermal process को will try to understand this in much detail. है ना? And if you see right now we won't be going into much deeper aspect. If you will be taking engineering, then you will be studying in mechanical engineering, IC engine and all these things. There will be talking about thermodynamics in much detail. है ना? Right now there is a very small scope in our hand. बहुत छोटा सा part we have to discuss. Okay, so we'll talk about now. Okay, so isothermal process. Okay, so isothermal process, if you see isothermal process, isothermal is made of two words. ठीक है, iso plus thermal. ठीक है, iso means same and thermal stands for temperature. Right? So you can say it's that thermodynamic process where temperature remains constant. है ना? So temperature remains constant. ठीक है, if temperature remains constant, okay, we know something called as Boyle's law. ठीक है, हाँ, one thing keep in mind, all this process we are talking for an ideal gas. Okay, ideal gas, see, it's a hypothetical thing, right? Ideal gas, like ideal gas, nothing exists in this real world. Okay, we can reach near about ideal behavior. In real life we have real gas. ठीक है, ideal gas जैसा nothing exists in this world universe, but we can reach towards ideal behavior if we increase the pressure, decrease the temperature. है ना? So near about ideal behavior we can achieve, but perfectly ideal gas we can never achieve. है ना? Real life में भी you have the same thing, no? We can never ever have some ideal thing. ठीक है, near about ideal behavior we can have. Okay, okay, so temperature remains constant, T is constant. Okay, temperature remains constant. If you remember, gas for which temperature remains constant, it obeys Boyle's law. है ना? So Boyle's law, ठीक है, so temperature constant means it will obey Boyle's law. ठीक है, if you are getting confused what was Boyle's law, simply use ideal gas equation. Okay, PV equals to nRT, that is also sufficient enough to understand this. ठीक है, Boyle's law, suppose you are getting confused, no, कि Boyle's law क्या था, what was that? So you can keep in memory like this: Boyle's and boil. Okay, water boils at fixed temperature, that is 100 degrees Celsius. Okay, so boils and boils. So Boyle's law and boils. Water boils at fixed temperature, that is 100 degrees Celsius, and Boyle's law, temperature remains constant. ठीक है, this is simple funda which you can use it to keep in mind. Okay, नहीं तो simply use PV equals to nRT, इससे भी काम बन जाएगा. With this also we can understand. Okay, number of moles constant, R constant, T constant, all these are constant. ठीक है, so we can say PV is some constant value. If PV is some constant value, you can write P is some constant upon V, or you can say P inversely proportional to V. ठीक है, okay, and that also we know it comes from the Boyle's law. ठीक है, P is inversely proportional to the volume. Okay, or we can say PV is some constant, जैसा हमने देखा, we have already seen it. Okay, now if I talk about nature, ठीक है, कर्व का नेचर क्या होगा, प्रेशर वर्सेस वॉल्यूम का कर्व देखें, विल बी समवट लाइक दिस, प्रेशर वर्सेस वॉल्यूम. नाउ इफ यू सी, दिस इज द इक्वेशन ऑफ अ रेक्टेंगुलर हाइपरबोला. ठीक है, दिस इज इन द फॉर्म ऑफ y इक्वल्स टू y इंटू एक्स इज इक्वल टू सम कांस्टेंट. तो ये इक्वेशन इज ऑफ रेक्टेंगुलर हाइपरबोला, ओके, सो योर ग्राफ विल बी समवट लाइक दिस. ठीक है, तो ये तो ग्राफ की बात कर ली. लेट्स टॉक अबाउट लिटिल अबाउट आइसोथर्मल प्रोसेस. ठीक है, थोड़ा अच्छे से समझते हैं. ओके, आई विल इरेज दिस. So for isothermal process, temperature remain constant. Okay, I'll write T some constant. ठीक है, अब देखो isothermal process it's a very slow process. ठीक है, it's a very slow process. First condition. दूसरी बात, okay, that container or that setup where we are doing this isothermal process has to be perfectly conducting, है ना. So container बोल दो, or you can call it to be setup, has to be perfectly conducting. Okay, why I'm saying there is a reason for this. ठीक है, perfectly conducting. ठीक है, डीपर एस्पेक्ट यू विल बी स्टडिंग इन इंजीनियरिंग कॉलेज. ठीक है, लेकिन थोड़ा सा टेक अ फील ऑफ इट, क्या होता है isothermal process. ठीक है, टू अंडरस्टैंड लेट्स टेक एन एग्जांपल. सपोज यू हैव अ सिलेंडर and you have a piston. Okay, and inside this you have some gas. Okay, the piston, the setup I am talking is purely perfectly conducting, है ना. ठीक है, and imagine on this piston we have small masses. ठीक है, छोटे छोटे मास, छोटा छोटा weight, small weight we are putting on the piston. ठीक है, okay. Now let's say outside temperature is for example 20 degrees Celsius मान लो, inside temperature is let's say 20 degrees Celsius. Why? Because they will be in thermal equilibrium, because it's perfectly conducting. Since it's perfectly conducting, outside and inside temperature is going to remain constant initially. Inside pressure, let's say P of the gas, whatever. Outside pressure, let's say external pressure. Okay. Volume, whatever the volume is. Now suppose slowly, one by one you start lifting this mass. ठीक है, इस mass को थोड़ा सा हटाएं. When you lift this, okay, right now this is in perfectly equilibrium. Right now this is an equilibrium situation. Okay. Equilibrium means neither piston is going up down, it's perfectly in equilibrium. Now suppose you remove small mass, one by one you start removing this mass. पहले इस mass को हटा दिया, you remove this. Now when you remove this mass, okay, because of that removal of the mass, okay, inside pressure will be more compared to the outside pressure. This piston will little bit lifted away, है ना, थोड़ा सा ऊपर जाएगा. When there is piston will try to lift up, there will be expansion, है ना. So there will be expansion. Because of this there will be expansion. If there is an expansion, अगर expansion हो रहा है, system has done the work. If there is expansion, temperature will decrease. Okay, temperature will decrease. If temperature decreases, let's say it goes to 19 degrees Celsius. ठीक है, now if you see outside temperature is 20 degrees Celsius, inside temperature is 19 degrees Celsius, and it's perfectly conducting. Okay, so automatically this heat will pass into it. ठीक है, same amount of heat will pass into it. Now its temperature will again change to 20 degrees Celsius, है ना. Again what you do, you remove the second mass. Again when you remove the second mass, there will again be expansion. Okay, if there is expansion, again there is a decrease in temperature. Again it will go to let's say 19 degrees Celsius. Again the heat will pass inside again, है ना. Again heat will pass inside it. Again its temperature will go to 20 degrees Celsius. So this phenomena will go on. Okay, and finally at the final situation, ठीक है, I started from here. Finally ये ड्रामा होने के बाद, after this drama, okay, overall scenario will be like this. One by one you keep on lifting the mass. So finally my system will be somewhat like this. Okay, final temperature 20 degrees Celsius outside, inside temperature 20 degrees Celsius, and overall there will be some expansion. ठीक है, overall some expansion will be there. Okay, of gas will be there. Okay, and to do this process I have taken very large amount of time. That's why I said it's a very slow process. One by one mass you take it out, slowly there will be expansion, and it will take a very long time. So that's why it's called very slow process, and we are maintaining this all the setup to be perfectly conducting. Why? Because I don't want temperature to remain, I don't want temperature to change, है ना. Okay, so this is a little bit idea about isothermal process. About this in much detail you will be studying in engineering college. Okay, which is right now it's not in our scope. ठीक है, the things which are in scope we'll talk about that. Okay, so I'll erase this. Okay, this was the feel of this isothermal process, what it is and how it actually behaves. Okay, now coming back to the topic, जो थिंग विच इज़ रिक्वायर्ड फॉर आर एग्जाम उस पर हम फोकस करेंगे, ठीक है। इधर उधर की बातें विल नॉट डू। ओके, सो आइसोथर्मल प्रोसेस में क्या था, टेम्परेचर कांस्टेंट, टेम्परेचर इज कांस्टेंट एंड वी आल्सो सॉ पी वी इज सम कांस्टेंट, है ना। इफ टेम्परेचर इज कांस्टेंट, ओके टेम्परेचर इज कांस्टेंट, कैन आई से चेंज इन टेम्परेचर विल बी जीरो, ठीक है। इफ चेंज इन टेम्परेचर इज जीरो, कैन आई से फाइनल टेम्परेचर विल बी इक्वल टू इनिशियल टेम्परेचर। If final temperature and initial temperature are same, if I talk about change in internal energy, delta U is given by U final minus U initial. Final internal energy I can write NF by 2 R T final. Initial internal energy you can write NF by 2 R T initial. NF by 2 R common, T final minus T initial, ठीक है। अब final and initial temperature are same, यहाँ रख दो, so this entire term will be zero. Can I write delta U is zero? इस तरीके से समझ सकते हो। सिंस टेम्परेचर रिमेन्स कांस्टेंट, चेंज इन टेम्परेचर इज जीरो, मतलब फाइनल विल बी इक्वल टू इनिशियल टेम्परेचर, चेंज इन इंटरनल एनर्जी इज गोइंग टू बी जीरो, ठीक है। सो इन आइसोथर्मल प्रोसेस चेंज इन इंटरनल एनर्जी इज जीरो। ओके ओके, सो आई इरेज दिस। सो सारे पॉइंट्स को लेट्स क्लब इट टुगेदर, है ना। P इज कांस्टेंट, ओके, in isothermal process, delta U I got it to be zero. Now let's apply first law of thermodynamics, ठीक है। first law of thermodynamics, it says Q heat given to system is equal to work done plus change in internal energy, है ना। since delta U is zero, ये term zero, so Q is equal to W, ठीक है। so we can say whatever heat supplied to the system will completely utilized in doing work. There is no change in internal energy, right? In the previous example also we discussed final temperature of the piston inside the piston was 20 degrees Celsius and there was overall expansion. So whatever heat I supplied will be completely utilized in doing the work, ठीक है। So sometimes they ask a question like this, no, which is that thermodynamic process in which heat supplied is completely utilized in doing work, ठीक है। So it is that process. So कह सकते हैं, okay, in this process, okay, heat supplied to the system is completely used in doing work, ठीक है। keep this in mind. Sometimes they can ask you trap question, conceptual question, which is that process in which heat supplied to the system is used in only doing work. So ये वो process है, isothermal process, ठीक है। okay, what else we understood? pressure versus volume का diagram, P versus V, we saw it was rectangular hyperbola, right? PV is some constant, ठीक है। so you can write y into x is some constant. In place of y we are plotting pressure, in place of x we are plotting volume, so y into x is some constant. So this is an equation of a rectangular hyperbola. So rectangular hyperbola will be like this, जैसे जैसे pressure will increase volume will decrease, है ना। okay, now let's talk about slope की बात करते हैं। now slope, slope of a xy curve, right? अगर कंपेयर करो y versus x ग्राफ से, okay, slope of this curve is given by dy by dx, okay, so dy by df gives me the slope. Similarly, if I talk about pressure versus volume graph, I need to find dp by dv, है ना। dp by dv will give me the slope, ठीक है। तो let's find it. dp by dv का वैल्यू क्या है? I'll erase this part. okay, so dp by dv value I need to find, ठीक है। so pv if you see it's constant, isothermal process के लिए this is constant and I need to find dp by dv जो कि मेरे को slope देगा। so if I differentiate both side with respect to volume, ठीक है, so d by dv both side constant, okay, so we know how to differentiate, chain u into v method use करेंगे। first I'll differentiate p keeping volume constant, then I'll differentiate v keeping p constant, है ना। so with this differentiation v go outside, dp by dv plus, now pressure I'll keep it out, I'll write dv by dv, differentiation of constant gives me 0, है ना। we can write like this. now if you see I'm getting term like that, dp by dv जो I needed it, right? so I can write this as dp by dv, okay, okay, v dp plus V dp by dv plus P dv by dv gives me 1 है ना, this is 0. So now we'll separate out dp by dv, this can be written as minus P by V. ठीक है. So slope of isothermal curve, slope isothermal is minus P by V. ठीक है, सिंपल. तो इस कर्व का स्लोप ऑफ दिस कर्व इज गिवन बाय माइनस P by V. इजी टू फाइंड, समझ में आ रहा है? ओके ओके, आई विल इरेज दिस. ओके, सो और बाकी सब, हाउ इज एवरीथिंग गोइंग इन लाइफ? सर व्हाट यू आर आस्किंग अबाउट लाइफ? लाइफ की वॉट लगी हुई है ना. ओके, आई कैन अंडरस्टैंड. सी दिस इज़ अ फेज ऑफ प्रिपरेशन, छोटी मोटी बातें होती रहती है. सो वी हैव टू टेक एवरीथिंग टुगेदर एंड वी हैव टू मूव ऑन, है ना. दिस इज़ ईजी फॉर मी टू से, यू विल से, नो आई ऑल्सो वेंट थ्रू द सेम फेज, है ना. आई कैन अंडरस्टैंड द थिंग्स गोइंग इन योर माइंड. ओके, हार्मोनल हाईजैक, ठीक है, ऑल दिस थिंग्स आर देयर, बट think about greater good, no, why you plan to crack the exam. Okay, so think about that and have confidence and prepare, और मस्ती करके पढ़ाई करते रहो यार, है ना. चलो, come back here. So isothermal process, what we discussed, we just discussed now. Okay, slope, pressure versus volume, slope of this, okay, dp by dv, we got it to be minus P by V, है ना. we got this to be slope. इसका मतलब क्या है? Suppose you have been given pressure versus volume का graph somewhat like this. Okay, corresponding to this, suppose they have given you pressure, let's say 5 P naught, and corresponding to this volume is 5 B naught, 5 B naught. Okay, and और क्या corresponding to this, ठीक है, corresponding to this point, let's say pressure is 2 P naught, corresponding to this volume is, let's say, 2 V naught. ठीक है, randomly I have taken some random data. Now suppose they ask you what is my slope of this curve at this point. ठीक है, ठीक है, तो यहाँ पे slope if they ask you, simply put pressure here and simply put volume here. ठीक है, तो pressure at this point, okay, if I talk about slope here, pressure at this point is 2 P naught and volume here we have is 2 V naught. ठीक है, minus sign, 2 cancel, I'll have minus P naught V naught. ठीक है, minus का why there is a minus sign? Simple reason is that, no, if you make a tangent on this, ठीक है, यहाँ का slope, if you check it, you check the slope, you check what is this angle made with this, right? Suppose this angle is theta, slope is also given by tan theta, right? Now this theta is greater than 90 degree, so tan of any value greater than 90 degree will be negative value, that's why we have a minus sign. ठीक है, simple thing. Okay. ठीक है, सो एग्जाम्पल की बात करें. सी इन रियल लाइफ यू कैन नेवर एवर हैव परफेक्टली आइसोथर्मल प्रोसेस. ठीक है, देन व्हाई वी आर टॉकिंग अबाउट, ठीक है, वी टॉक अबाउट आइडियल थिंग एंड वी ट्राई टू इम्पोज इन प्रैक्टिकल रियल लाइफ. ठीक है, तो इफ आई टॉक अबाउट एग्जाम्पल ना, आइसोथर्मल का प्रोसेस का एग्जाम्पल, इफ यू सी मेल्टिंग ऑफ आइस. ठीक है, मेल्टिंग ओ स्पेलिंग रॉन्ग, मेल्टिंग ऑफ आइस at 0 degree Celsius. ठीक है, suppose you have a ice क्या होता है? At 0 degree Celsius it is in solid state. Okay, you supply some amount of heat, ठीक है, and it will be changing into liquid, ठीक है, at 0 degree Celsius only. If you see there is no change in temperature, delta T is 0 here. You supplied heat, it was in a solid state, my state changed to liquid, but there is no change in temperature. There is a change in state, but there is no change in temperature. Okay. Okay, so this is an example of isothermal process, but again I am saying it's not perfectly isothermal, क्योंकि perfect जैसा nothing exists. Okay, anyway, now let's talk about work done. ठीक है, work done के बारे में बात करते हैं. See, first law of thermodynamics we applied and we got Q equals to W, है ना. So means heat supplied is equal to work done. So let's talk about work done. ठीक है, see, work done is given by integral PdV. ठीक है, this is a general form of work done. कोई भी process हो, any process is there, work done formula is integral PdV. Okay, for isobaric process, if pressure is constant, you take pressure outside, you integrate V, then you will get P delta V, है ना. So we are talking about isothermal process. Now if you see here, I need to integrate pressure with volume, ठीक है. Now both are of different species, right? You cannot integrate pressure with volume. या तो first you convert this pressure in terms of volume, or you convert this volume in terms of pressure, anything, ठीक है. Okay, so I need to do something about this. Okay, so what should we use? Temperature is constant, we know, for isothermal process, ठीक. तो क्या यूज करें? Ideal gas equation, can we use it? हाँ, we can use it. PV equals to nRT, right? So pressure, can I write nRTV? N constant, R constant, T constant, V, right? So now you can see pressure is in the terms of volume. इसको we can use it. You use it and put it here, ठीक है? So we can write work done integral nRTV dV, ठीक है? Now N constant, R constant, T constant, इसको बाहर निकालो, take it outside. I can write nRT integral dV by V, ठीक है. Now suppose if I am going from state number 1 to state number 2, so I'll put limit V1 to V2, ठीक है. I'll put the limit V1 to V2. Now integral dV by V क्या देता है? Is it giving me log? Integral dx by x gives me ln of x, है ना. So same way it can be written as nRT integral dV by V. This will give me the ln V V1 to V2, ठीक है. Now ln क्या होता है? It's a natural logarithm. I think in maths, maybe your maths teacher had taught you. ln is nothing but logarithm, right? ln is natural log. Okay, this ln is nothing but log to the base e, है ना. ln is nothing but log to the base e. तो या तो you can write in logarithm or you can write in terms of log also, ठीक है. Okay, पहले simple form में let's write it. W we can write nRT ln V2 and V1, right? So upper limit minus lower limit. So V2, V1. So this can be written as ln V2 minus ln V1. I can write like this. है ना? So this can be further written as nRT ln V2 by V1. ठीक है, ये logarithm का property है. Okay, I'm using this property ln of A by B. This is ln A minus ln B. हाँ, ln institute नहीं, logarithm. Okay, anyway, ln A by B is ln of A minus ln of B. Okay, I can write like this. So I'm getting a formula, I'm getting this formula, ठीक है. बस ये keep this formula in mind. Remaining formulas you don't need to worry about that. You don't need to remember any formula apart from this, ठीक है. Now let's use this formula and play with this, ठीक है. I hope you are able to understand this, ठीक है. So work done I'm getting nRT ln V2 by V1. इसको मिटा देते हैं. Let's erase this. Okay, so work done formula I'm getting to be nRT ln V2 by V1. Just remember this, remaining you can forget. Now if you want to express in terms of log to the base 10, है ना, log to the base 10, same thing, in somewhere they'll write you in terms of log to the base 10. You can write this as 2.303 nRT log to the base 10 V2 by V1, ठीक है. ln से log to the base 10 you can write like this, ठीक है. बाकी keep this formula in mind, और ये conversion you should be knowing. बाकी you can forget about everything. Okay, now you can express in terms of pressure also. You can play with this, ठीक है. इस formula के साथ you can play. PV was some constant, है ना, for isothermal process. You can also write P1 V1 equals to P2 V2, है ना. Can I write P1 by P2? This can be written as V2 by V1. इसको उठा के you keep it here. Okay, so this can be written as 2.303 nRT log 10 log to the base 10 P1 by P2, है ना. या तो प्रेशर के टर्म्स में लिख लो, राइट. सो वर्क डन, कीप दिस फॉर्मूला इन माइंड. बाकी सब यू कैन डिराइव बाय योरसेल्फ, है ना. नाउ यू कैन प्ले विथ nRT ऑल्सो. nRT यू कैन राइट P1 V1 इक्वल्स टू nRT, है ना, और P2 V2 इक्वल्स टू nRT ऑल्सो, ठीक है. बिकॉज नंबर ऑफ मोल्स कॉन्स्टेंट, R कॉन्स्टेंट, T कॉन्स्टेंट, सो यू कैन राइट फॉर दिस ऑल्सो. या तो P1 के टर्म्स में यू पुट इट हियर, P2 V2 के टर्म्स में यू पुट इट हियर. चॉइस इज योर्स, जिसके साथ खेलना है, हाउएवर यू वांट टू प्ले यू कैन प्ले विथ. ओके, so this was about isothermal process. I hope you understood it. Okay, so let's discuss example based on isothermal process. कैसे क्वेश्चन आते हैं. So let's read the example, है ना. Consider PV diagram, pressure versus diagram for an ideal gas shown in figure. Out of the following diagrams, which represents a temperature versus pressure diagram, TP diagram. Okay. So if you see this graph, okay, suppose they have not given, it's an isothermal process, we don't know. How will you decode it? Huh? If you see pressure versus volume diagram, it's like this, and they've also given pressure is some constant upon V. Huh? Can I use this? So pressure is some constant upon V. Can I write PV is equal to some constant? Okay. And we also know PV equals to nRT, ideal gas equation. Ideal gas equation. If you compare this to, can I write nRT is some constant? Number of moles constant, R constant. So my temperature has to be constant, so that total value becomes constant. So we can say temperature is constant. If temperature is constant, can I say it's an isothermal process? Okay. Isothermal process. So this is how you have to decode this. Okay. In the figure they will not mention whether it's an isothermal process or whatever. Okay. So you have to decode it first. So isothermal process means temperature is going to remain constant. Okay. Now let's filter it out. Eliminate the options. First option, if you see, as pressure increasing, temperature is increasing. Okay. So pressure increases. Okay. In this graph we can say there is increase in temperature, but my temperature has to remain constant. So this option is gone. Okay. Okay. Second option, temperature versus pressure. Okay. As my pressure is constant, temperature is increasing. Here you can say P is constant, but temperature is increasing. But temperature has to remain constant. This is also gone. Okay. Here you can say as my pressure is increasing. Okay. I'm going from 2 to 1 pressure. Okay. In the graph, if you see, I'm going from 1 to 2. Right. In the graph, we can see as my pressure is decreasing. Okay. As I'm going in this, pressure is decreasing, volume is increasing. Right. So from 1 to 2, pressure has to drop. Okay. From 1 to 2, pressure has to drop. If I go from, but here they have given I'm going from 2 to 1, right? So 2 to 1, my pressure is increasing. So 2 to 1, pressure is increasing, or in a way you can say 1 to 2, my pressure is decreasing, vice versa, and temperature remaining constant. Okay, so this is my correct option. Clear? Temperature has to remain constant, and as I go from 1 to 2, my pressure has to decrease, right? So third is the correct option. Fourth option is also eliminated. Clear? So like this, try a few more examples based on different thermodynamic process. Okay, we'll meet in the next class. Have a nice day. Thank you.